So this is video 1.6a in college algebra, and this section is the algebra of functions. You like my cool orange I'm going to be using today. And one of the things that you need to remember, and I'm sure you do, is that when you have a function that's written like this, that means if I have a function of f of, let's say, 3, that means I put in whatever this is in for my equation and get an answer. So the function of 3, which means when I put 3 in for x, my y value is going to be 5. Alright, so that being the case, let's look at a couple things that we're going to be doing in here. So I'm going to leave f of x being x plus 2, and I'm going to put g of x equals x squared plus 1. So if I put a g of 2, that means 2 squared plus 1, which is going to give me 5. Okay, so just a reminder there of what that value that we replace in there for x is. So let's say, for instance, we want to add these two functions together, this function and this one. And the way we write that, you can write it like this. Okay, basically what that means is the y value here and the y value here equals something. So we can write it that way. It's usually shortened to this. Okay, and so either way works. So what that means, if we're looking at an example like example 1, it tells me that f of x equals x plus 1, and it says g of x equals square root of x plus 3. Alright, the question is, A, what is this? Well, that's going to be x plus 1, this function. Since we're looking at these f's and g's, plus square root of x plus 3. Can't do anything there, so that's your answer. But what if I have with a 6 there? That means f of 6, whoops, plus g of 6. So I'm going to put 6 in for this and 6 in for that. So I get 7. X plus 1, 6 plus 1 is 7. G of 6 is going to go here, which is the square root of 6 plus 3 is 9. So it's going to be 7 plus 3 equals 10. So the answer of those functions added together is going to give me 10. Okay. Let's continue on here and look at C. C says f plus g of negative 4. So that means I'm going to take f of negative 4 plus g of negative 4, and f is f of x was x plus 1, so I'll rewrite it here, and g of x was square root of x plus 3. Okay, so we're going to put negative 4 in here for x, and we're going to put negative 4 in there for x. So I get negative 3 plus square root of negative 1. Okay, one of the problems with this is, remember when we were talking about domains, we said two things. It will not work if it makes your denominator 0, and it will not work if it makes your radical negative. So that being the case, since this negative 4 makes our radicals a negative, negative 4 is not in the domain of g. Therefore, f plus g of negative 4, this right here, does not exist. That can't exist because it made one of our functions a negative number. Okay. So let's keep going here with example 2. Given that f of x equals x squared minus 4 and g of x equals x plus 2, find each of the following. Okay, so the first thing they're asking us to do is find the domain of f plus g. What numbers actually are going to work for f plus g? Are there any numbers that when we put in here for x or here for x are going to give us our negative radical or a denominator of 0? No. So f of g works. Let's look at f minus g. Well, that doesn't change either because all we have is a minus sign. We're going to get no fractions in either one of those that give us a denominator of 0, and we're not going to get any square roots. So we're good to go there. How about f times g? That ain't going to make any difference. How about f over g? That isn't going to make any difference. So all of these work. The domain f is a set of all real numbers. The domain g is also the set of real numbers. So we're okay, except if we have this here, f over g. So let's do that. F over g would be x squared minus 4 over x plus 2. So what we're doing is we're looking for a number that's going to make that 0, and that number is negative 2. So the domain for f over g would be all numbers negative infinity to negative 2, but doesn't include negative 2. And we're going to start at negative 2, doesn't include negative 2, and go to positive infinity. So that's actually the domain for f over g. Okay, and that's usually the case when you're talking about division here. See, this is multiplication, subtraction, and addition. We're not going to get any fractions here, but right here it's naturally a fraction. So we have to look at the denominator. What's going to make that 0? And we're going to exclude that from our domain. And once we exclude that, our domain is the set of real numbers except negative 2, except what makes that 0. All right, let's look at B. And the B part of this example, let's see, I'm going to just scribble that out because I can't make it just go away. All right, B says, what is f plus g of x? So let's write this as f of x plus g of x. Okay, and we're going to add those two functions together. So we're just going to take x squared minus 4, which is our f of x, and add x plus 2. So that gives me x squared plus x minus 2. I'm going to go ahead and write that correctly in the right order, and that's it. Now what happens if we were to make that f plus g and f minus g? So it's going to be the same way. X squared minus 4 minus, because we're using a minus, we're going to make a parenthesis there because it's minus this entire thing, not just the x. X squared minus 4 minus x minus 2. We're going to get that. Okay? Now, let's see. They're asking us to do, that was C. D is they're wanting us to multiply. So we've got fg of x. And that gives us whatever f is times whatever g is. And you're going to use the FOIL method. And you're going to get x cubed plus 2x squared minus 4x minus 8. Alright, once you're done with that, then you are going to get division there. So we're looking at, let's see, what part? E. F over g of x. So we're going to have x squared minus 4 over x plus 2. And if you look at this, you can see that's the difference of two squares. So we're going to write it like this. And we're going to cancel that with that, and we're left with that. So f over g of x equals that right there. Okay, so let's look at the last one. And it says g of x. So we're going to take our g right here, x plus 2, and it just says multiply that function by itself. So we get that. Okay, and when we end up doing the math, we get our FOIL x squared plus 4x plus 4 for that answer. Okay, that's it. All right, we're going to get into difference quotients, and difference quotients are really, really important because this is some preliminary calculus stuff. So you will see this when you're developing formulas in calculus, just kind of getting started here. And this is really, I had mentioned, I think earlier, as far as calculus, the average rate of change, and we talked about slopes of tangents as they hit graphs and that kind of thing, and that's where all of this comes from. So I'm going to take a picture here. I'm going to end here, and I'm going to start the next video with the difference of quotients, middle of page 137.